So this TDY window title is this little thing that we see up here, like the tab and window title that's set on the terminal. Something in the CLI is doing this. So just as an example, we can ask questions of our code base to figure out like how something works. And it starts by doing search text, which is effectively a grep across the files in the directory. It's found some candidate files, and it loads the file itself, like it thinks it's the right file, just to check that it's correct and get more context. And then it's able to answer the question. Hi, everybody. My name's Mark. Yeah, I'm in the DeepMind developer relations team. I'm based here in Australia, so it's nice to like get to talk to people in the region. This is about the Gemini CLI. It's kind of aimed at kind of a broad range of people. I want to cover quite a lot of stuff, so I'm going to start with like the very basics and introduce the CLI, but hopefully also cover like a fair breadth of content. So if you've used it before, there's still something useful here for you. I'll try and speed through it as quickly as I can to save time for Q&A at the end. So drop any questions you have like in his chat, and if I can answer them as I'm going, I will, but otherwise we'll try and come back to them at the end. So at its core, the Gemini CLI is an interactive command line tool that we built to work with Gemini, specifically our Gemini 2.5 Pro Flash models. The thing that makes it different from other like Gemini tools like Gemini.google.com is that it has an agent loop. What this means is it's just able to kind of continue iterating on a task. So you ask it a question and it will use the tools that it has available to keep going and working towards the goal until it's finished. We say that it's context aware. What this means is that in comparison to other kind of more generic tools, it has information about your operating system. So like it knows if you're running on Mac or Windows or Linux, and it has access to like limited access to your file system as well. And importantly, it can run binaries from your system. So this can mean things like running ls to see what files are in the directory, or more complex tools like running JQ, GraphQL commands, or even like tools like FFmpeg for like basic video editing. We say that the CLI is project oriented. What this means is that you would typically run it from like a project directory, so like somewhere like a workspace, maybe like a Git repo that you've checked out. By default, the tool will have access to the files that are in that directory and like awareness of the files that are in that directory. We don't expect you to run it from like the root of your file system, but you can if you want to. You can also run it from like a downloads directory if that's something you need to do. But we typically expect you to work from like a software development workspace or kind of scratch directory. So I can talk about this for a while, but I think the best thing to do is to jump in and actually show you the tool working. Okay, so we run it with Gemini. And this is what it looks like. The first thing you would expect to see on a brand new install would be this authentication dialog. Typically, most people will just log in with Google. This is where you would just use your web browser to log in using your standard like Gmail account. And with this process, you get our like 1,000 free API calls a day using 2.5 Flash and Pro. I use the Gemini API key because this is just an easy way to set up like a build account if you want to use like unrestricted 2.5 Pro access. If you're already using Google Cloud, you may have a Vertex AI account that you can use. And this allows you to kind of use centralized models, use your regular Vertex AI billing that maybe your business is paying for. But yeah, you've got a few choices here. They all talk to different backends, but it's all the same model. It's really just billing and accounting is the difference here. Now, the first thing I will show you in the tool is not actually in the tool, is these GEMINI.md files that we have. So these are like a set of pre-canned instructions that you can build for your projects or for yourself. I'm checked out in the Gemini CLI repository here, and the team has a Gemini.md file checked in. So this is like a reusable file that we can use across the team for everybody who works on the project regularly, and for any contributors to kind of load up if they want to make changes to the file, to the project. And what we've got in here is just a number of instructions that kind of describe like all of our engineering practices and how we as humans would want to build like on this project, and therefore like it's the same instructions that we give to the AI model, and we expect that Gemini will follow these when we make changes. And it means that like anyone in the team who wants to build a feature or fix a bug is working with the same set of instructions, and then any like PRs that we generate should all follow the same kind of engineering practices. So some of the stuff we've got in here is like our details about like how to build and run the project with npm run preflight, details about tests, so like the test frameworks that we use, how we do mocking, how to do React testing, and then we have some kind of generic instructions about things like Git. Stuff like this isn't strictly necessary because the tool can figure it out itself, but it usually just saves like a round of like tool execution to figure this stuff out. We also have in here things like our engineering style guide, so like how we expect classes to be built, how to use, we've got here, how to use any types, or not in this case, and just general kind of like engineering style guides that like as an engineering team member, you would figure out from like looking at the code, but we can kind of like save a bit of time both for people and for the model by like writing this up front. And so you can use these in your projects by just dropping it into the top level directory. But it is like a tiered structure. So the CLI will look in all of the subdirectories as well for any GEMINI.md files. So you can set up like a front-end directory with front-end specific instructions, a back-end directory with back-end specific instructions, and you can set up a global directory for like in your home directory with things that you want to use across all of your projects. The benefit of using them in subdirectories like front-end and back-end is that if you've got a lot of instructions and you don't always need them, like if you're working on a front-end component, it can be distracting to the model and sometimes like overload the context unnecessarily by including back-end instructions as well. So if you just jump into your front-end directory and run Gemini, it just won't be able to see any of the back-end instructions. So I'll show you my GEMINI.md file that I use. I do lots of demos, so some of these aren't like super practical engineering things, but I like to use GitHub. I have this CLI tool installed, so rather than using like remote Git commands or trying to figure it out with the Git tool itself, I prefer GH. Some stuff about how I use Python, how I interact with Google Cloud Storage buckets. I'll show you my presentation tool a bit later. I have tools that create slide decks. I have tools that write emails. So I've got like instructions on how they should act. I have some information here about like how to use tools to copy information to the clipboard. This isn't strictly necessary anymore because the CLI supports like a copy command, but I have it here just for extensibility. Now we'll go back into the tool. You can see that it has a note here describing the GEMINI.md files that it's found, so you know that they've been loaded. What I will show you now is that there are a number of tools built into the CLI. So most of these do the things you would expect, like being able to edit files, find things in your current directory, read, make changes, grep across a number of files. But we also have tools in here for Google search. So this particular tool allows, it uses the Gemini API's Google search feature to, do a sweep of the web and find anything that might be relevant to particular queries. It's helpful for like looking at latest library information, or if you need to get information that is just not available in the model's memory. We also have this web fetch tool. This allows the model to go and grab data from the internet. It will use the Google search index by default, but if that URL is not available there, it falls back to like using local tools like curl or wget. And I guess the last interesting one here is save memory. So this is a tool that allows the model to append information to your GEMINI.md files. So if you're going through a workflow and you've done something that you think is a task that you're likely to do again, you can tell the model to like save that, call it this particular task, and then in future you can just call it by name, and the model should be able to remember it. You can also just use it for like personal style guide stuff as well. So you can say something like, remember that I like to use conventional commit syntax. And because this is just like a raw text prompt, it will kind of model. The model realizes that it needs to make this save memory tool call, and it has updated my Gemini.md file. So now I can see tail Gemini. You can see we've got an extra block at the end now that just describes like, my personal preference. And because this is in my global Gemini.md file, this is saved across all of my future Gemini CLI sessions. But the main thing we want to see with the CLI is actually doing some edits. So let's have a look here. We have, I'll get it started first. So how is the window, TTY window title set? So this TTY window title is this little thing that we see up here, like the tab and window title that's set on the terminal. Something in the CLI is doing this. So just as an example, we can ask questions of our code base to figure out like how something works. And it starts by doing search text, which is effectively a grep across the files in the directory. It's found some candidate files, and it loads the file itself, like it thinks it's the right file, just to check that it's correct and get more context. And then it's able to answer the question. So that's pretty cool, but obviously we can also use it to make changes. So we can say something like, can you update this title to include a Unicode star? You'll see here that it will use the information it already has in the context about which files contain the code, and it may reread the file if it thinks it needs to, but it will generate a diff, get us to like review it and make sure it's okay, which is done here. Now, with this dialogue in place, you can say, yes, this is good, I like this. You can say, yes, always allow edits if you are comfortable that the changes you're going to make are pretty safe. You've also got the option to modify in an external editor. So if you choose this option, you can get it to open in like VS Code or Vim or whatever tools you have available. And this allows you to kind of make changes to this specific file that you might have done in like a code review situation. You also have the option to say no. No is effectively just breaks out of the agent loop that it's going through. It does terminate it, but it's not necessarily a complete termination. You can use this as a way to like provide more feedback to the model. So if you think the change that it's made is going in the wrong direction, you can say no. Actually just use an emoji sparkle instead. And it will continue on because it still has the full context of the conversation that's happened before and the code change that was just shown to us. And so you can use the no like escape to kind of give feedback to the model and continue on. Now, while we're in here, I'll also show you that we have some tools, some commands that are built in. So commands in the CLI start with a slash. There are loads of things here. They're all displayed in help. If you're ever not sure about like a command that you think exists, you can hit help and get some information. These are extensible too, so I'll show you extensions in a second, but you can write your own slash commands. If there's tasks that you find that you are doing repeatedly, you can add your own. The CLI also has this shell mode. So you press exclamation mark, and instead of sending the text in this box to the Gemini API as a model prompt instruction, it will run it in your local shell and display the output. So you can print the directory, you can list the files. The benefit of this is that you don't have to escape the CLI, which is handy, but it also includes this output information in the context. So any future like conversation that you have, any future prompt instructions will know about the commands that you executed. And so this can be a helpful way to like include information from another file or make the model aware of something that you need to do manually. You can also, as noted here, you can also reference files explicitly using @ syntax. So you can, tell me about contributing. And because it knows the files in the current directory, it gives you like autocomplete here. And what this does is it will read the file and include the entire contents of the file in the prompt that is sent to the model. And it works with text files, obviously, it works with source code. Because Gemini is multimodal, the CLI is also multimodal, so it supports PDFs, it supports images, it supports videos, and it supports audio files as well. So this can be a easy way to do things like napkin sketch to code app if you just want to drop in a file this way. I'm going to go over some of these features here. So I showed the GEMINI.md tiered setup briefly, talked about multimodality, but I'll leave this open for my own reference and jump back to the terminal and talk quickly about sandboxing. So you can see that in this interface, it already has this like no sandbox option like indicator here. This is the default operation. The CLI sets up some like soft safeguards to make sure that the tools only have access to read and write files that are in the current project directory that it's launched from. But it is possible for like a malicious user or for just a completely rogue AI response to access other files through like shell commands or other mechanisms. The way to add more safety here is to use a sandbox. So you can run Gemini with the sandbox flag. And in this case, I'm running on Mac OS. So it is using the Mac OS seatbelt system by default. You can see it down the bottom here. Seatbelt is an OS level sandbox that the CLI provides a list of tools and files that it has access to. And then the operating system itself prevents this binary from running any other commands or from accessing any other files. So it's a pretty good level of safety. Gemini CLI also supports Docker and Podman. So if you have them on your system or you're running a non-Mac system, you can set up an actual container. You have the ability to configure these. So the default images are pretty restrictive and they don't include many tools by default, but you are able to configure it. You're able to use custom images, and there's like a number of overrides you can set here. What I will show you here quickly as well is that the settings that I specify by the command line, and I'll do a few of these in this session, but these are all also settable via a global Gemini settings JSON file. So here I've got the theme set already, but the equivalent for sandbox would be to add sandbox true, or if you have a specific need, you can do like sandbox Docker or something like that. And then when you run the tool, it will automatically have the sandbox enabled unless you disable it. Now, what was next on our list of demos? MCP. So the CLI supports MCP tools. I have a few set up here already. You can see 3 MCP servers. Press Control-T or run /MCP to see what is running, and you can see their status. Green lights are good. That means they're running and working. The few I have here, one is Context 7. This gets API documentation on demand. So if you need to use a library that is brand new or the model doesn't know about, or you just want up-to-date docs, Context 7 can go and pull those for you. I've got one here for Google Slides. This can just hook up to the Google Slides API, generate slide presentations, add information that the model is available, or the CLI is able to generate for you onto slides. And I have an extension that I made myself for connecting Gemini API docs directly in via a MCP server here. So MCP is handy because there are loads of MCP tools that already exist on the internet. If you're using some third-party SaaS system, chances are they have an MCP available that you can plug into. I'll show you how that works here. These again are also in your Gemini settings JSON file. So here I have my Context 7 command. It's run using npx with some args, and you can also specify environment variables. This kind of configurability gives you like the flexibility to run pretty much any binary that you can. So things like npx, uvx, and pipx will allow you to like download and run remote packages on your machine, on demand, which is pretty handy. But you can also use like environment variables to set things like credentials, which is what I've got set up here for my slides MCP. I had 3 extensions. There's only 2 in here, 3 MCP, sorry. The missing third one is in Gemini extensions. Extensions give you a way to like bundle up a little bit of configuration. So one that I made here is just a personal Git repository. It contains, well, I do check you. I'll show you the Gemini extension file. It contains a little bit of metadata. It contains an MCP server definition in exactly the same format as in settings.json. You can provide a context file as well. So this allows you to give specific instructions. So for mine, I've got information on like how to use the API doc specifically. In this file, you can also add things like custom / commands. So if you want to set up something like a deployment system, or you've got a specific like prompt that you like to use to generate plans and implementation, you can bundle it up as an extension. You can share it with your colleagues or the internet or whatever you need. Yeah, it uses the exact same configuration structure as the regular Gemini CLI settings. What was next? So that was extensions. Headless mode. So as well as running in the interactive UI that we just saw, the Gemini CLI has this headless mode where you can just run a prompt directly from the command line. So you can say something like, summarize my last week's Git logs and write an email to like email.message. So this will run that prompt. Because we have safeguards in place that will like request that tools be permitted and that file writing is authorized, I'm just going to turn on YOLO mode. This will just automatically approve everything. And you'll see if it runs quickly that it works the same. Like it will invoke the tools like Git to like generate the logs themselves, processes those logs, and then writes it out to the file that I specified. This is handy for things like running cron jobs. So if you have like a scheduled job that you need to generate an email of teams, history every week, you can use headless mode to do something like this. It's going to take much longer. I do have one I prepared earlier. I'm going to cancel it. It should only take another couple of seconds, but this is the one I prepared earlier. And you can see it like it's able to just generate email and dump in the logs you'd expect. There are a number of other like commands you can use in the CLI. You can specify things like the model, prompt, sandbox, and all this configurable stuff. All of this is also available through the settings.json file that I showed you. But now we'll jump on to telemetry. So if you use something like a telemetry collection system as part of your business or personal workflow, the CLI supports writing to an OTel OpenTelemetry endpoint. So you can run a local one, or it can connect to like a Google Cloud hosted telemetry endpoint. If I go Gemini telemetry, this one will write to local. I'm gonna get a local server running so you can see it working. Oop, looks like I've already got one running. Start a fresh one. We'll run Gemini. I'll just say hello. While it's doing that, I will, where is it? Load up. So I've got it configured to write to this JSON file. So I'm just going to grab the last log message that's there just so we can see it. And you'll get an idea here that does contain, it contains things like the prompts that are sent, the exact, oh, can you see that? Is that coming through on the screen? No, it's not for me either. Okay, I'll quit out and I'll do it in this window. TQ. So this is the JSON file. It contains details about the tool, obviously. It contains information here like, where is it? Contains statistics. So you can see things like the requests that are used. You can see the model specifically that it used for each of the requests, what status they are, details about latency. There's information in here about like token usage as well. And it does also contain like log information in here, which this one doesn't, but they're in there if that's helpful for whatever it is that you're doing. Next is checkpointing. So I showed you sandboxing as a way to kind of control, limit the amount of access that the tool and the model have when running, especially in kind of unchecked mode. Another feature that we have for safety is checkpointing. We say Gemini checkpointing, I'll set it in settings. And what this does is create a shadow Git repository behind your working directory. And so I will show you a change here. So if we say replace my README with just jokes. And so yeah, what it does is it creates a shadow Git repository, and anytime a tool is called, like a mutating tool like write file, it will take a checkpoint. So the tool, we have a backup to fall back to basically. So say yes. And I will, got a number pressed up, ignore that one. Now we can see that we have restore. We have this checkpoint here that allows, doesn't look like the multi-tab thing's working. Not working. But this allows us to jump back to the point in time where the file was edited, restores it to that file point, that snapshot, and then continues on with the process. So the tool itself is like rerun. So in this case, write file is there, but we can modify it, we can make changes, or we can just abort. And we'll see that README is still in its original state. So this, especially with sandboxing, is a good way to make sure that the model can't really go off the rails particularly badly. The two of them together is a good combination, but use whatever is appropriate for your particular setup. I'll also show chat, save, and restore. So something that you can do, like a common pattern that I find myself, and I'm sure other people do as well with Gemini, is getting it to talk through a particular problem, coming up with a plan or some possible next steps that we could do. Sometimes they are branching, like maybe we do plan 1, plan 2, or plan 3. Maybe they are sequential and we need to jump back and forth between them. Something we can use to help us in this particular workflow is, let's say, give me ideas for refactoring the docs. What we might want to do is jump back to a point in time in our chat session. So restore our chat history as it was at a particular point in time. So maybe we've got ideas for refactoring the docs here. We get a few different options. We try the first one, we deploy it to a server. We try the second one, we deploy it to a different server, etc. But at each of these, we want to roll back the changes from the first approach, whatever that was, and then continue on. So once this thing has finished talking, there we go. We can say chat, save, ideas. And then we can get it to go ahead and do something, or we can quit and come back in and chat, resume. We call it ideas. So this will put us back in the exact state that we were in before. So this is helpful for jumping back and forth in a particular workflow, but the persistent across session checkpointing is also helpful, because sometimes you just need to get out of the CLI, and it's nice to have a backup. or like a session you can jump back into. It's also helpful for like debugging sometimes because it does show you the full response history in that file if you need to check it out. Now the next one on the list is context compression. So I will load up a slightly longer session. Okay, it's not that much longer, but like down in the bottom right, you get the view of the model's context usage. So the 2.5 models have a 1 million token context window, which is fairly big. Like it does hold quite a lot of information, but when you're working with things like code and files on your file system, that can like quite quickly blow up. And so the CLI has a context compression feature that when you hit that limit, you can it will prompt you automatically to compress it, and it will do a deep, fairly heavy compression, trying to keep the rough idea of shape of the conversation, but without all the implementation details. If you want, you can run compress yourself, and then it'll run in the background, but then it will come back with a result of how much it's able to save you, being able to save you in terms of tokens. This is also a place where like the chat session saving can be helpful. Like if you, because this compression can be quite aggressive, it can be helpful to take a snapshot first. And that way, if you lose any important information, you can restore your old snapshot and kind of do a manual compression or take a different approach if you need to. I talked about how pretty much all the command line flags can be set up in your settings.json file. It's a helpful way to reuse your specific settings across all of your sessions. Enough of the demos for now. I'll talk a little bit about how the CLI is built. So what might be surprising is that this is a Node.js app. It uses React specifically. So React is typically like a web-based framework. It uses web components to build up a user interface. The CLI also uses it. It uses a library called Ink, which takes these web components in this like UI structure and renders them as a terminal interface. You can see this here. You can see that like it does work exactly like a standard React app where you get these, HTML style components. I can show you something else like the input prompt here and see that the where you actually type the text into it's a box, it has text, the box can grow, and this is just it's a flexible way to build user interfaces for the web, and it turns out it's also pretty effective for the command line. The app is structured as like two particular layers. So we have our core package, which contains all of the agent loop and the logic for running commands and interacting with Gemini. And then there is a CLI package that sits on top of that. It contains the interface. We've done it this way so that it's extensible. So if you want to reuse the interface on a different backend, or if you want to build your own interface as say a desktop app or a web app or something, like you can do that. The repo is set up so that it's easily forkable and buildable this way. We also have in here a couple of system prompts. So the project is open source, like everything's on GitHub, and we're pretty proud of that fact. And one of the things that people have been interested in is actually seeing the system prompts that we use for the agent itself. So I will show you those. This is the main system prompt. We have pretty standard stuff like you're an interactive agent, you do software engineering things. We have some core mandates, about not making assumptions, try and adhere to existing conventions where you can. What else do we have here? Confirm ambiguity and explain your changes. It's primarily a software engineering tool. Like it can do other things, but software engineering is the main goal. So we do have like a standard workflow that we think the tool should follow. Interestingly, we have some opinions about how to build apps when the user doesn't specify. So for example, if you've said that you want to build a 3D game, we will use 3.js by default. If you want to build a mobile app, we use like a Kotlin multi-platform or Flutter. And there's a few other things here. We have tone and style as you'd expect for something like a user-facing agent. There's information about the tools that I showed you before. So, reading files and executing stuff in the shell. And then there's just some conditional instructions about like how to use the sandboxing, and if we've got a Git repository, how to interact with that. And then we have a number of examples which just kind of use like a few shot approach to train the model on exactly how it should respond. Also in this file down here is this compression prompt. So this is, if you're interested, this is how it does the actual context compression down from the 4 million tokens to whatever it compresses it to. But I will show you the other prompt here. This is the first turn context. Switch tabs. So this one is the first turn context. So this is where the model learns about your actual system. So we are the Gemini CLI. This is today's date. We are running, Windows, Linux, whatever. And here's the directory that we're in. Now, what it does is by default, it doesn't give you a full dump of all of the files in the directory. This tool here, the folder structure one, will do like a tree view of the files, like does a little ASCII tree of like, here's a directory, here are all the subdirectories, here are all the files. But it has some smarts in there to do things like remove node modules, Python virtual environments, anything in git ignore is all filtered out. The model doesn't need to know about any of that stuff. And it will trim particularly long directories or busy directories or deep structures. So the idea is that it gives like the important kind of outline of the files that are there without sending the contents. This keeps it quick and snappy. And then if the model needs to read files, it makes the tool call itself to understand this. So even on the very first interaction you make with the model, it already knows about the files that are like in the directory. Now when we launched this, it was pretty overwhelming, the reception we got. Like GitHub stars aren't particularly meaningful in themselves, but we're up to like 65,000 stars now, and like it's been amazing, almost too amazing. We've had like loads of GitHub issues and pull requests come in that like a very small team has had a hard time keeping up with, but it's still very exciting, and we're like stoked to have everybody involved. Because we're very like bullish on being open source and being part of an open source community, very recently we've announced that our roadmap is completely public as well. So we have a couple of files here. The roadmap.md is just kind of our philosophy about our roadmap. But if you want to actually see the things that we have planned for the coming quarters and further ahead, we have this roadmap here, which is on GitHub. And you can see that we have high-level themes here of like improving agent performance, automation, etc. So these are things that you can jump in and comment on. We have discussions where we have most of our like community announcements go, and where we can talk to people about like features that they're interested in, and gauge what people really want to see next.